So on to the business of the day. It's with, as I said, great pleasure that we welcome FACTS, Food and Allergy Consulting and Testing Services, to the Food Focus Webinar Wednesday platform today. We're really excited because they're going to be talking on an area that they are definitely experts in, that being rapid kits and the way that you can go about detecting food allergens in your production environments. And so we're very excited to be able to hear from them. You can see that we've got two great specialists that will be chatting to us today. Comaine van Zyl, she'll be going through allergen control, validation versus verification, and Hezri van Heerden will be talking about the different options that you have available when it comes to rapid kits and the pros and the cons of both of these two options. And so let's get into finding out a little bit more about our presenters. It's great to have the ladies from FACTS with us today. Often we have the gentlemen, but it's great to see that there's a fantastic team, and it's great to chat to Comaine and Hezri. As you can see, she's a food technologist. She spent most of her career really focusing on food allergens and training people and consulting to assist you as organizations to get it right. And she's got 10 years of experience, and it's in the trenches experience, making sure that you know which rapid kits to choose. She's going to be talking to us today about the specific, as you can see, proprietary Allergen Bureau Vital program. And this is a very specific allergen risk assessment process. She's a registered trainer, and FACTS are in fact the only Vital endorsed trainers in Southern Africa. So this is really important because the process that she's using is obviously something that is accepted internationally. I like the fact that she likes things simple and rational, and she loves being inside food factories. So maybe you need to send her a shout out and invite her to come along to your factory and understand, so that she can see how things work, and more importantly, she can advise you on how to do things better. She's joined by her colleague Hezri van Heerden, and she's a food scientist and a technical service developer at FACTS. And really, she's there to grow client relationships and to develop the services. She's a food science graduate from Stellenbosch University, and she's been involved in a number of areas in the food industry, including dairy and meat. And she's gone straight from her degree into FACTS, and of course got a lot of experience there with allergen control. She understands the challenges that you're facing, and so that's why I'm saying make sure you ask her questions today, because from that point of view, she'll be able to share her extensive experience to help you to overcome your obstacles. And she would love to be able to assist you. And so please be aware that FACTS will be reaching out to you after this webinar to tell you details of upcoming training, so that you can enhance your skills when it comes to food allergen control. So it gives me great pleasure to hand over now to our presenters. And so this morning I'm going to be bringing online Comaine. Comaine is going to be helping us with the first part of today's presentation. And so Comaine, over to you. Right, Comaine, I'm now asking you, won't you unmute yourself for me? There we go, we've got everything organized, so you should be able to see Comaine's screen and hear Comaine and see Comaine. Over to you.
Thank you. There's always the unmuting situation going on these days. I think that's the most common phrase this year, you're on mute. Thank you very much for the introduction. As mentioned already, we're going to talk about rapid kits today, or allergen rapid kits today, and we're going to talk about what needs to be considered when choosing a rapid kit and how does it fit into allergen management. But before we do that, I think it's maybe just a good idea to create some context. Where does rapid kits fit in? Why do you want to use it, etc. So obviously we know that our goal as food industry is to produce products that consumers want to buy, right? But also we need to make sure that the products that we sell are actually safe. And to do that, we implement food safety systems in our factories of which allergen management is these days a standard feature. Allergen management, as you guys know, comprised of different components, of which are the actual controls, and those controls need to be validated and verified. And allergen testing, whether it is lab testing or rapid system, support the validation and verification process. So before we start talking about allergen controls and testing, etc., let's just quickly recap to why allergen control is necessary. So the overarching reason why we need to have allergen control is to protect the consumer, right? So adverse allergic reactions or adverse food reactions that are non-toxic, which is mediated by the immune system. So it's an abnormal adverse food reaction to the protein in food. It's mediated by the immune system. Symptoms of food allergens or allergic reactions are generally acute. There's a quick onset. And in some severe cases, allergic reactions can be fatal. It can be life-threatening. But it's not in all cases, it's rare cases. Generally, the type of symptoms that patients experience are what we call quality of life symptoms. So it limits the quality of life, or it influences their quality of life. There has been a marked increase in the amount of people that are diagnosed with food allergies in the past few decades. And to date, there is no cure for food allergies. It's also known that very small amounts of the offending food can actually cause an allergic reaction. As little as, example, 0.2 milligram egg protein is known to maybe result in a food allergic reaction. So patients, to protect themselves, need to strictly avoid the product or the food that they are allergic to. So food allergic patients and the caregivers of food allergic patient children are always looking at product labels and precautionary labeling statements to determine whether the food product they buy and eat is safe for them to consume. So let's just quickly look at allergen management. So obviously, as I've already mentioned, we need to have or implement allergen management to protect the consumer, because allergic reactions can lead to illness and death. But if there's an undeclared allergen in a food product, it can also lead to food recalls, loss of money, loss of consumer trust, and ultimately a degrading or damage to your brand. In addition to that, allergen management has become a standard part of any food safety standard. For example, it's a standard feature of the GFSI benchmark food safety systems or standards. In addition to that, it's also a legal requirement to prevent allergen cross-contamination and in a facility, for example, and to label allergens adequately. And I think the piece of regulation that most prominently and directly speak about allergen control is Regulation 45 in the labeling regulations R146, which state the following. If there's a risk for cross-contamination in a food processing facility, due diligence shall be exercised to prevent the occurrence of such contamination, and an allergen control plan or policy shall be implemented. So if there's a risk of cross-contamination, you have to implement an allergen control plan. In the case where precautionary labeling is utilized, this shall not be used to circumvent GMPs and an effective allergen control plan. So you can't put a precautionary labeling statement on a product if you haven't done everything in your power to prevent the contamination from happening in the first place in the form of an allergen control plan. And then lastly, in the case where precautionary labeling is utilized, the risk, the manner of assessing the risk, and the steps taken to avoid the risk of allergen cross-contamination shall be documented. So if you have an allergen precautionary labeling statement on the product, you need to be able to prove that it is really necessary. And that is where a tool like vital risk assessment, for example, come into play, which is a whole field in itself. Allergen cross-contamination can be defined as the unintentional incorporation of a food allergen into a product. So the addition or incorporation of a food allergen into a product where it's not supposed to be. Now, from experience, we know that allergen cross-contamination is generally sporadic. So some batches might be contaminated or not. Some ingredients might be contaminated and some might not. And allergen contamination can really happen at any stage of the production chain. So think from farm to when the product leaves your facility in its final primary packaging material. So allergen control, we implement allergen controls to minimize or prevent allergen cross-contamination from happening, for example, in a facility. And it's best when your allergen control is based on a HACCP approach. So common allergen controls that are production controls that are implemented include, but is not exclusive, there are many others, but include dedication and segregation, for example, storage in separate areas, production scheduling, rework control, and then allergen cleaning, and then obviously validation and verification. So validation and verification is how we show and prove and show and monitor that our allergen controls are effective and remain effective. But it's very important to remember and take note that validation and verification is two very different processes. And this is best illustrated when we look at cleaning or allergen cleaning, for example. So allergen cleaning validation is when you develop an allergen cleaning method, seek to prove that when we clean in this way, we will actually remove all the allergenic residue from our surfaces, equipment. So the objective is to prove that this method will work. So it's done initially, so when you develop an allergen cleaning method, and then thereafter, if something changes, if you introduce new allergens, and if something went wrong, if there was an incidence of cross-contamination, and then typically most companies revalidate an allergen cleaning method annually. But it doesn't need to necessarily be done annually. Verification is when you gather evidence to prove or make sure that the previously validated cleaning method was actually done correctly. So you establish how something needs to be, or equipment needs to be cleaned during validation, and verification, you just prove or check that it was actually done in that pre-validated cleaning method way. So verification is typically done ongoingly after, for example, an allergen cleaning. How do we do validation and verification? Both validation and verification include visual inspection, and that's very, very important to remember. Visual inspections, and then that is supported by some type of testing. Now, the type of testing will differ between validation and verification. So when you do validation, you typically want to have a quantitative result because you want to know how effective your cleaning was. So that there you need a number. So there you want to use a quantitative method. So generally ELISA, mass spectrometry, or PCR is used, and those methods are generally used or done in a lab. Verification, because of the nature of verification and because often production waits for you to approve that cleaning was done correctly, needs to be done by a system that can be done on site. For example, this is where the rapid kits come in. So it needs to take very little time to do these tests. So the typical types of rapid kits that are available, and Hezri is going to talk about that some more, are protein swabs, lateral flow devices, and then some people also use ATP. The type of samples that you take for each is also very different. So it's very, very important to include next product samples when you do validation, because I always say the proof is in the pudding. You need to know, based on your next product sample, whether cross-contamination occurred or not. And then if it did occur, do you need to precautionary label? So validation will always include a next product sample, and that is then complemented by, for example, surface swabs, rinse water, air plates, etc. Where with verification, because of the technical capabilities of the rapid kits, you are often limited to the type of samples that you can test. And in most cases, it is rinse water, surface swabs, and with newer systems, you can actually also test ingredients and final product to some degree. So now we've spoken about testing. So let's just quickly drill down a little bit more in testing. So allergen testing is not always just done to validate and verify controls, but in some cases, allergen testing play a role to determine whether contamination happened, either whether you received an ingredient contaminated or whether contamination actually happened on site. Obviously, allergen testing needs to be done to support allergen-free from claims, and in general, it's done to show due diligence. So when we look at the available methods for allergen testing, there are generally two types. The first is commonly done in what I refer to a fully kitted laboratory, and those methods are best for validation because they are highly technical and you need trained and experienced technicians to perform them. It's infrastructure intensive in the form of physical structure, equipment, etc. It's expensive to run and it's time consuming. Where the rapid kits, which is best suited for verification, is best suited for verification because it's easy to use, where you need very little technical expertise. It's a lot more cost effective, it's mobile, and it takes a lot less time. In most cases, less than an hour to run a rapid kit test. So before I hand over to Hezri, let's just quickly look at the type of methods available for a validation, the lab-based tests. So there are basically two types of methods. One, we refer to the first, we refer to as direct methods, where we go and look for the protein that actually caused the allergic reaction. So you directly detect for the agent that could cause the allergic reaction. And then the indirect method, which is the DNA-based methods, where you go and look for the DNA that is associated with the allergen or the allergic food. So the two most prominent protein-based methods or direct methods are ELISA and mass spectrometry. And these methods yield quantitative results. They're very sensitive and very specific. So previously, ELISA was the go-to method, but more and more mass spectrometry is gaining its space in the sun for allergen testing. When ELISA and MS is not available, that's when you start looking at DNA-based methods, for example, PCR. Often PCR is not quantitative, and plus because you're not looking for the agent that is actually causing the allergic reaction, you need to know how to interpret these results. So now we've looked at how we control allergens and where rapid kits fit in. So now I'm going to hand you guys over to Hezri. So Linda, if you can just quickly switch off the camera so that we can do our musical chairs, it would be great.
Okay, but I just need to make sure everybody knows. Make sure everyone knows now Hezri is coming on board because you're labeled as Hezri, and I'm getting people saying, "Who's this again?" So yes, here we go, girls. Musical chairs. Right, everyone. So we're bringing Hezri online now, and she's going to be taking us to the next part of the presentation. So when you're ready, Hezri, we're just going to ask you to switch your camera back on.
Okay, thank you, Linda. I am here. Okay. Can everyone, is my screen sharing?
I can. Won't you turn that? Perfect.
Okay, great. So as Kumain said, and thank you, Kumain, for setting the scene and introducing allergen control validation versus verification, I'm now going to take a more in-depth look at rapid kits, so the role it has in allergen verification. I'm going to look at the different systems available, the disadvantages and advantages of each of those systems, as well as all of the factors you need to consider before choosing a rapid kit, and also to be aware of the capabilities and limitations of these kits. So let's get started. So firstly, rapid kits, as the name suggests, it's a rapid solution for on-site allergen detection. As Kumain mentioned, it cannot be used for validation purposes. It can only be used for on-site verification and screening activities. And just to reiterate again that it must be supplemented with visual inspections, checking control documents, because it cannot be used in isolation. No testing solution is a silver bullet, so it's very important to use it together with visual inspections, because if a line is visually not clean, it will most likely also give a positive result with the rapid kit, and therefore you will almost waste a test if you do it so. It can be used to test rinse waters, surface swabs, and in some cases, ingredients and finished products. And the great thing about rapid kits, it's mobile and no additional equipment is necessary. So you don't need an extensive or elaborate laboratory on your site. You can use everything you get in the little kit box to do the testing. Okay, so now let's take a look at the application thereof. So what problems do it really solve for you? So just some few examples. Was the validated cleaning procedure performed correctly? So proof that the validated procedure was done as it should be and that the line is clean. Is the production area free of contamination? So before you start producing your next product, you can use your rapid kit to test, is the line clean or do you need to re-clean? Are the delivered goods safe to use? So this example is where you will need a lateral flow device that can actually test products to screen to see whether there is any contamination in the raw materials you have received. And this is also something to keep in mind when we come to the point where we discuss what you need to consider, because even though a kit might be suitable to test food products, it's not to say it's suitable for all types of food products. So it's very important to keep that in mind, but we'll go a little bit more into detail about that later. And lastly, is the equipment clean? So this is not just the normal equipment. It can be, you can use it to test utensils, buckets. It's quite versatile. Okay, so let's take a look at the different systems available. So several systems have gained popularity in the recent years. There are 3 particular kits that have been represented well in the industry, and those 3 types of kits can be divided into 2 groups. The first group detects protein. So this is with lateral flow devices, also called dipsticks or strip tests. They are allergen specific, so they detect specific allergenic proteins. So you get a kit that can only detect milk or egg, it's specific to allergens. But there is also total protein indicator systems available, and an example of that will be protein swabs. The other group is those that detect ATP, so this is the energy source of cells. And we're going to take a look at each of these kits to look at the pros and cons that each one has. So starting with lateral flow devices, these are qualitative or in some cases semi-quantitative immunochromatographic tests, and they are based on ELISA principles. So they use an antibody system. They are much easier to use and quicker to use than their full ELISA counterparts. Once again, they're allergen specific, so you get kits that are specific for soy, peanut, or almond. You can use these kits to test surfaces, rinse waters, and in some cases limited food products. They can only be used for cleaning verification, so they do not replace laboratory methods, and they are generally quite sensitive. Looking at the disadvantages of these kits, unfortunately, most of them are only qualitative. So it only gives you a yes or no. It doesn't give you the level of contamination. So if you do get a positive, you're not sure about exactly to what extent the contamination is. And with the semi-quantitative kits that are available, so for example, there is a gluten kit where you can actually set the limit of detection at 5 parts per million, 10 parts per million, 20 parts per million, or 40 parts per million. So those are in the rare cases where a kit is semi-quantitative, but generally most of them are qualitative. Even though they work on the same principle as the ELISA methods, they are less sensitive than laboratory methods and also less accurate. So for validating claims and for doing your validation studies, you must use laboratory methods. Results need to be verified. So very important, whatever kit you use, to use it in conjunction with laboratory methods. So when you perform your validation, to check your verification kits, that the results that you receive from the verification kits are in line with the laboratory results. So if you get a positive from the laboratory, it must be the same with the lateral flow devices. And a very, very important point is to look at what is being tested. So what allergenic analyte or protein analyte does the kit target? Because let's say, for example, at your facility, you have whey powder, and now you want to purchase a milk rapid kit.
If you purchase a kit that only targets the casein protein in milk, it will not be suitable for your whey powder, and it will not detect contamination thereof at your facility. So very important to look exactly, is it detecting casein, is it detecting whey, or is it detecting both, so total milk protein. Okay, so let's take a look at protein swabs. So the rationale behind these swabs is because allergens are proteins, a surface found to be protein-free should be allergen-free. They're also quite relatively sensitive. Some systems detect as low as 3 micrograms protein. They can be used to detect, to test surfaces and rinse waters. So you can't do any product testing with protein swabs because products do contain protein. They will always give you that positive result. And they are generally cheaper than allergen-specific tests, so lateral flow devices. And that is because you generally get them in quite a lot of more tests per unit than that of lateral flow devices. Looking at the disadvantages, so they're not specific for allergens. So if you do get a positive result, it's not to say the protein is from an allergenic source. So firstly, if you do get a positive, number one will be is it from an allergenic source, yes or no? And if it is from an allergenic source, which allergen? Is it milk or is it egg? Especially if you have multiple allergens on site, you won't be able to say which one it detected. And also with the more sensitive systems with the protein swabs, generally a heating block or dry block is strongly recommended and advised. You do get systems that do not require heating blocks, but it is highly recommended. And also with the systems that do not require heating blocks, they're generally not as sensitive, so that will be the less sensitive systems. And when it comes to allergens, you would want to prefer to have the more sensitive system available. So just the protein swabs work also on a color indication. So generally the color will change to show was any protein detected. A lot of times people will ask, what about ATP swabs? Can they use ATP kits for allergen verification? So it's important to remember that ATP kits detects the presence of energy. It's the energy source of cells. So this is more associated with microorganisms and food soils. There's not a direct measurement of allergenic proteins. And for that reason, together with the fact that the correlation between allergenic residues and ATP results are not well studied, it may yield unreliable results, and therefore it's not recommended to base your allergen verification on ATP. So that's a quick overview of the different systems available. So what needs to be considered when you choose a kit? How do you choose the correct kit for your facility? Unfortunately, as most things in life, there's not one size fits all. There's no perfect kit that just fits every requirement. The suitability of a kit greatly depends on the desired outcome and on a variety of factors related to the manufacturing environment. So do you have multiple allergens on site? What number of allergens do you have? What is your capabilities as a facility and what is your requirements? And we're going to take a bit of a closer look now. So let's look at the type of questions you can ask to guide yourself on choosing the right kit. So always start off with what is your objective? What problem do you want to solve? What is your desired outcome? Because let's say you just want to see whether a surface is clean. After performing a cleaning procedure, you can use a protein swab or a swab. But if you want to screen a product to see if incoming ingredients contains any contamination, you will look at a lateral flow device that is suitable for products. It's very important to firstly determine what is your objective with your rapid kit. And a lot of times with this step, you would actually see that you require validation and not verification. So it's always important to start with what is your objective when it comes to testing solutions. Next is which allergen do you want to detect? So this is the example I gave with the milk. You need to decide what is your target protein, what is your target analyte. Then you need to think of, do you need an allergen-specific system? So let's say you make multiple allergens on site, you have 7, 8 allergens. It might not be a feasible option for you to get an individual kits for each of those allergens. So then in that case, you can potentially look at protein systems, which is more universal. Do you need to be able to test rinse waters, surface swabs, and all materials? So it's very important to remember that the sample you're testing is the indication of what you're going to get. It's a representative of what you're looking for. So if you take surface swabs, for example, it will only give you information about the surface. It will not give you information about the products or the products produced on the line after cleaning. Lastly, how sensitive must the system be? This will all go back to your risk assessment, where you will determine what is your requirement in terms of the limit of detection of the kit. So how low must it be able to detect? Once you have asked these questions, you should have a good idea of what systems you should be looking at. And then you can go to the next phase, where you need to then look at the challenges and limitations of each kit. So unfortunately, no test doesn't have any limitations. Every test out there, you need to consider what potential downfalls it may have and what things you need to consider before you perform the testing. Because if you just buy a test kit without looking at this, you might be not only losing money if the kit is not giving you reliable results, but also it's a food safety risk, because if you get a result that is negative and it's actually because something that was wrong with the kit or it's not suitable for you, it can be a risk to the consumer then at the end of the day. Okay, so what needs to be considered in terms of kit capabilities and your facilities capabilities? So we're going to look at the sample matrix. So what is actually being tested, the nature of the allergen, which is the nature of the contamination you have, your resource capabilities. So this is more in terms of the practical and physical capabilities of your facility. And lastly, some general kit capabilities you need to be aware of. Okay, so starting with sample matrix. The matrix being tested is almost equally important as the kit itself. So this refers not only to, is it rinse water, surface swabs, or product testing, but the product you are testing, can the matrix potentially interfere with the results? An example we can give for this is high-fat matrices. So let's say you're producing a sorbet and a full cream ice cream. The sorbet generally has a low fat content, whereas the full cream ice cream has a higher fat content. If both of those products contains equal amount of peanut contamination, and you use a lateral flow device that detects peanuts, you will get a positive result with the sorbet, but maybe because the ice cream has such a high fat content, it may give you a false negative result. So it's very important to look at your matrix being tested, and the same goes with protein swabs. For example, we were aware of a client. They produced snack foods that had a seasoning that was quite high in fat content, and they used protein swabs to check the lines after production, after cleaning after production. And the lines were visually dirty, but if they swab, they get negative results. So they actually then went to swab a product, the actual snack food that had the seasoning, and still they got a negative result. So at the end of the day, it was that the high fat content in the seasoning masks the proteins, and therefore it was undetectable by the protein swabs. So the results they were getting, they kept thinking, oh, it's negative, we can start producing again, but actually it was a false negative. Cross-reactivity. So what we mean by this is when the proteins in one substance are very similar to proteins in another substance. And the lateral flow device kit cannot actually distinguish between those proteins. So you would get a false positive result because it detects something else that has similar proteins. So just to give you an example of this is with certain almond kits that targets almond protein is cross-reactive with apricot stone, so the seed of the apricot. So it actually tests positives when it detects apricot seed, even though it's not the almond protein. So you'll get a false negative and you'll think, okay, the product is contaminated. Meanwhile, it's just cross-reactive with another ingredient in there. So it's very important to also look at cross-reactivity. Representative samples. So when you sample, to make sure it's a good representation of what you're trying to determine. So if you are using swabs, do not go and swab a clean, flat surface that is, easy to clean. There's no texture on the surface. You can clean it quite easily. You would rather go and take the surface swab to test corners or grits or something that's a little bit more difficult to clean, because that will be a better representation of your cleaning and whether it was effectively done. Same with food products. Make sure that when you do use food products for testing, that you get a representative sample of the batch. Very important to homogenize prior to testing. So for example, if you are testing a food product, let's say it's only contaminated on the outside of the food product, but you just take a sample of the product inside, you might get a negative result and then not detect the contamination. So very importantly to homogenize your samples before testing, and to be vigilant about hook effect. So hook effect occurs when a sample is so highly contaminated, it gives a false negative. And this is especially with lateral flow devices. Some kits do have built-in systems to show if a sample is highly contaminated, to show that highly positive, but other lateral flow devices doesn't have this. So it can actually give you a false negative. So if you do suspect that, you know, a product is highly contaminated or a surface is highly contaminated, to do a dilution series of the product, just to ensure that you do detect the positive contamination at the end of the day. So looking at the nature of the allergens, so the nature of the contamination, when you do risk assessments, you will always refer to whether the contamination is readily dispersed. So is it homogenized or homogeneous throughout the product, or is it particulate? So it's randomly dispersed and it's only pieces of the allergen that is dispersed throughout the product. When it is particulate contamination, it will be non-homogeneous, and generally the risk with particulate contamination is also much higher. So once again, when you do test a sample, it's very important to homogenize the sample so it can be a representative sample of the testing. Then another factor you need to consider when it comes to the nature of the allergens is there any processing step that might alter the proteins of the allergens? So for example, hydrolysis or fermentation can alter the proteins that it is no longer detectable by the rapid kit. And we're going to look a bit at the science of that now, but don't get boggled too down on the science. It's just to give you an idea of what we mean by that the proteins are altered and cannot be detected if there is highly processed samples. So if you think about a protein and an intact protein, it will have the binding site, which the antibody of the rapid kit will bind to detect the target analyte. So the antibody will bind to the binding sites and you'll get your positive results. In the case where it's been processed, it can be denatured. So the protein structure changes, and as you can see, the yellow in the intact protein is the indication of the binding sites, and as you can see, once it's denatured, it does look different. And then the antibody cannot bind to the binding site no more, and you will get a negative result, even though the protein is still in there. Same with hydrolysis, it means that the protein is basically broken down. Once again, the binding sites are broken and the antibody can no longer bind to it, but it is still present. So when you look at kits, it's very important to consider your own process. So is there any fermentation? So for example, with beer making or sourdough, you will get hydrolyzed gluten, and general gluten kits won't be able to detect those hydrolyzed proteins. So looking a bit at your resource capabilities, so your physical, practical capabilities of your facility, it's important to think about financial resources, because let's say you do have 8 allergens on site and you want to get an allergen specific kit for each of those allergens. It can get quite expensive, and therefore a total protein system might be a more financially feasible option for you. Rapid kits, they are quick to perform, but you need to think about the timing. Each kit does have a different amount of time you require to perform the test. And very importantly, you know, if you are under pressure that, you know, that they don't say, okay, no, it takes too long to perform the test, just start with the production again. Or in the case, you know, especially with these kits, there is a set period of time you need to wait or to perform the test. And if you read the results before that specified time, it might give you unreliable results or inaccurate results. So timing is very important to also look at to make sure that you get a kit that fits into your schedule. Also, with trained staff, the kits are very easy to use, very user-friendly, but certain kits are a little bit more difficult to work, and therefore you would need some basic technical knowledge to perform, because it would either involve dilution or extraction or pipetting steps. So you need to have your a set of staff that is able to perform those tests and train them how to correctly use the kit, because once again, if you do not use the kit correctly, it will not give you valuable results. And very importantly, to have technical support structure available. So for example, with FACS, what we have done with supplying rapid kits, we have positioned ourselves not to only be the kit supplier, but to be able to help clients, you know, choose about what kit they should have for their requirements, to identify their requirements, to look at all the capabilities and limitations of the kit, to help you interpret your results, to help you compare those results to laboratory results, and to just ensure that you have the right kit for you and give you the necessary technical insight that you need to perform the rapid kit tests. So lastly, just looking at some general kit capabilities. Once again, looking at the detection limit. So is your kit sensitive enough for you? there is not just one lateral flow device for peanut out there. There are quite a few different lateral flow devices for peanut. So you need to determine, based on your requirements, how sensitive should your system be. And then based on that, look at the kits available, look at their detection limits, and determine which one will be sensitive enough for you. Also very important, how is it measured? So if it says, they indicate usually the limit of detection, what it detects. So you need to see, does it detect the protein? Do they just give it as total? So do they just say it detects soy at 5 parts per million, or does it detect soy protein at 5 parts per million? Because that is also a big difference if you need to do your own conversion step. Besides looking at the sensitivity of kits, you also need to look at the selectivity. So looking at what was the kit standardized against, what target analyte does it detect? Because, for example, there's also a range of gluten kits out there, and each kit detects a different target analyte of gluten. So very importantly to look at what is being measured actually, and which one will be suitable for you. Looking at raw and processed proteins or both, can the kit detect both or only one? Whenever you perform your test, ensure that standards and controls are used. So use your positive and negative controls to ensure that it is able to actually detect the allergen, and making sure that the kit is validated. So what do we mean when we say the kit is validated? We refer to matrix check. So is the rapid kit suitable for your specific matrix? So how do you do this? You check by looking at kit validation reports. So your kit supplier should be able to give this to you, and the kit validation reports will show what was the kits checked against, which matrices. So flours or dairy products give you those specifics. And very importantly to note, even though a kit might in their validation report say it has been checked against a certain matrix, it's still not to say it's going to be suitable for your specific matrix. So always then do your validations together with the testing laboratory. So just to give an example, at FACS, we have a service where we can check your matrix for you, where we do laboratory accredited methods and compare it to the rapid kit results to ensure that they are comparable, that they're in line with each other, and that the kit is suitable for your specific set of circumstances as well as your matrices. And once again, include your control samples, because if you test the sample that actually contains the allergen and it's negative, it means it's not a suitable test kit for you. So rapid kits, just for something interesting, it's not only for allergens. You get other types of rapid kits out there. So for example, at FACS, we also have kits for meat species to detect meat species in soils and food samples. It works on species-specific serum proteins that it detects, albumin specifically, which is quite high generally in raw meat. So these kits can be used to detect meat adulteration as well as contamination in raw meat samples. You also get kits for mycotoxins, so all the different types of aflatoxins out there. You also get lateral flow devices for this, and the same goes for GMO. You actually also get GMO kits, which is also immunoassay-based systems. And Kumain will now do the conclusion for us and conclude the series for us. So Linda, if you don't mind quickly switching off the video again for the musical chairs.
All good, guys. Here we go. Right. For those of you that are now sort of waiting, and while we're getting ready for the last few slides, please, we have got a couple of questions that have been coming through, but please won't you make sure that you pop your questions into the question bar so that we can ensure that we ask all of these questions. This is a really complicated subject, so make sure that you are ready, with your questions. Right, ladies, back over to you. Thanks, Kumain.
Okay, great. Can everybody hear me?
Yes, you're not on mute.
Great, awesome. I'm always on mute, so I'm very sensitive to that. Okay. So, in conclusion, FACS has been involved with allergen management for many years. And for us itself, it has been a journey. So allergen control obviously is a legal and a GFSI food safety standard requirement. Allergen controls need to be validated and verified. And this is typically where the rapid kits come into play. So rapid kits are a quick and easy and cost-effective way of testing and verifying allergen controls on site. But once again, as Hezri has mentioned, there's no one-size-fits-all system. You need to be aware of the technical capabilities of the kits and also the shortcomings of the kits, and also how that will come into play with the type of samples and product, type of samples that you want to draw and the type of product you make. All right. So just to conclude, as I've mentioned, FACT is always very focused on supplying our clients with a holistic allergen management bouquet of services, which in our case started with allergen testing. Everything for FACT started with allergen testing. And then we started engaging with allergen regulations, helping clients figure out how to label allergens, when to label allergens, what must it look like, which then resulted in us starting to engage and include allergen training and consulting services, helping clients actually set up the allergen controls. And then when tools like Vital became available, we started engaging in risk assessments, helping clients to determine when will a certain amount of contamination actually become a risk to the consumer, when do you need to precautionary label or not. And that is why the progression to helping clients choose the applicable rapid kit for them for verification purposes was just a natural next step for us. So our objective is to be a supporting system for clients in general when it comes to allergen management. So now I'm talking just about the allergen portion of our business. Obviously, we have many other services as well. But we are here as a supporting structure. So with Rapid Kits, our role, or we see our role as helping you, number one, determine which rapid kit is going to work best for you, considering all the parameters Hezri has mentioned. But what we also do behind the scenes is we actually check out all these different type of rapid kits, and we choose those ones that we know are actually high quality and will yield best results. And then thereafter, we can help you with training, and then obviously you can source the kits from us as well. So it's a technical support service with regards to the allergen rapid kits as well as the supply. So I think we can go over to questions. I think that is, in conclusion, our presentation. The questions, we will probably play musical chairs between me and Hezri. So I will start off in the chair, and if I cannot answer, I will hand over to Hezri.
It's all good. It's all good. I think we're all looking forward to how that's going to go down. But even if you move the camera so that both of you are kind of in the screen, I think that would also work.
So we're going to break all our COVID management rules and sit really close to each other.
Put your masks on, and then we can take it from there. Okay, ladies, a great presentation. I have to say my head is spinning, because I think that, the last point that you made, Kamain, about this being a journey, I really do think that at the end of the day, this process requires a lot more than we initially understood or anticipated, and it's something that we cannot afford to take lightly. I almost feel like the picture that you should leave us with is that picture of all those poor little kiddies with their swollen eyes, and we often say it's such a small percentage of the population, but you cannot say that to a mother who is sitting in the emergency room with a child who looks like that. So please, to all of you out there that are food manufacturers, we do really need to take this seriously because of the potential life-threatening consequences. Right, so I've got some complicated questions for you. So I hope you had your cornflakes this morning. Okay, good question here from Justice. Justice is asking, during allergen cleaning validation, I think it's probably verification, but because I think in terms of the way you explained it, but he has a very good question here, because is it necessary to inoculate the surface with a specific amount of allergen in question? Now, you've mentioned the positive and the negative controls, and making sure that the thing can actually, the test kit can actually pick up what you are wanting it to pick up. But I think what his question is that is it sensitive to a particular level, in which case I need to make sure that I test it at that level?
So generally, that approach is not taken because the extraction of the proteins from different matrices will differ. So the aim of, for example, when it comes to rapid kits is just to actually test a positive control and make sure that the kits can detect the allergen in the positive control. When you start looking at testing actual ingredients and raw materials, there the inoculation or the spiking will come into play. So when, for example, there are gluten kits, as Hezri has mentioned, that you can set the limit of detection, 5 ppm, 20 ppm, 10 ppm, 40 ppm. And if you have, for example, a cutoff of 20 ppm, and you want to test ingredients or finished product, you need to make sure that that kit can actually detect at those various levels, and that will include that checking, matrix checking that we refer that to, or what we call that will include actually inoculating or spiking a sample at those levels, and then determining or checking that the rapid kit can detect the contaminant or allergen at those levels. So, but generally for surfaces, no. Generally you will just test a positive control. Yes, the allergen is there, it is detected, and then after cleaning, swab and test the product, or swabs or products, to determine whether everything has been removed. But it does play a role when you're actually doing checking, matrix checking for screening. Just as a side note, that is what we typically call recoveries, and that is part of method validation when it comes to accreditation of the method in the case of the lab.
So that's really where you're wanting to make sure that the control is being done up front, and that all of that work is being put into the test kit, so that when I use the rapid test kit, I'm relying on validation that's happened in the laboratory to ensure that it will detect at the specific levels that it is supposed to detect at.
Yes, so but those two go hand in hand. So if you're going to use the rapid kit for actual product testing, then you still have to confirm that the kit will detect the allergen at those specific ranges, or in the specific ranges that you want.
Yeah, but I think what you're saying is very important, because there is a difference between approaching product testing and surface or cleaning testing. So
very different.
Okay, so that's hopefully, Justice, that answers your question. If not, please pop me another one to support that. We've got a question here, and I think you gave us the answer, but let's see whether there's one around. Is there one set of testing kits for all allergens?
No. I'm going to hand that one over to Hezri.
So I'm not sure how much of you can see me. I know the plant is maybe taking a bit more of the spotlight, but so no, there's not one test that detects for all the allergens. Like I mentioned, there's total protein indicators, so it detects protein from any source, but that means it can be allergenic or it can be any type of other protein. And then you get specific systems for specific allergens. So you get a lateral flow device specifically for milk and a lateral flow device specifically for soy. I think the only case where I have seen lateral flow devices where it's for more than one allergen is when it's for tree nuts. There's actually a kit available that detects about 4 or 5 different tree nuts in the one kit. So that's the only situation. But otherwise, you only have the total protein systems where it detects any protein, as well as the lateral flow devices that are allergen specific, except for the tree nut example I just gave, where it does detect more than one allergen, but it's then 4 or 5 different tree nuts. So I hope that answers the question for you.
Yeah, it does. Sticking with that, Hezri, just you mentioned the importance of understanding the denaturation of the proteins during your process and understanding what that means with regards to the allergen kit. So Justice has a question here, and I've got the same one. Is the allergic protein component in whey powder structurally different to the one found in milk? In other words, would I have to test to detect milk and to detect whey powder if I'm using both ingredients, for example, in a yogurt, for example, and I've got a lactose-free yogurt and then I've got a normal yogurt?
Yeah, so to answer that question, we need to go back to look at what are people actually allergic to. So in milk alone, there are about 40 proteins that we know, 40 proteins in milk. Some of them fall in the casein group and some fall in the whey group. And some people are allergic to casein proteins, and some people are allergic to whey proteins, and some people are allergic to proteins in both groups. So that is why, for example, it's important to know in the case of milk, for example, which milk portion does your product contain and which milk portion does the rapid kit detect. So no, it's not needed to test for whey and for milk protein. You just need to know which, for example, milk protein is in your product, and you need to know which milk protein the rapid kit, or any method for that matter, detects. Because if you use majority whey protein and you use a method that detects casein, you are going to get a false negative. So it often goes hand in hand in understanding actually what people react to, and understanding that different people react to different proteins in products, and different people have different tolerances to, for example, the same protein. So in short, no, you don't have to test for total milk and whey. Yes, the proteins that people are allergic to in casein and whey is structurally very different, and different people are allergic to different proteins in milk.
And just to add to that, once you've identified, what proteins you have, so if it's whey or casein, it is important to look at your process to see, is the processing also altering those proteins? Because certain kits say that it can't be used for highly processed samples, so if it's used for fermentation. So you need to look at how does the allergenic proteins, how will it change during the processing steps, and will the kit then still be suitable to detect it?
Okay, so, but I'm just thinking now, I'm looking at the product on the shelf and I'm looking at it as a consumer. The warning is just going to say milk. In terms, okay, so I might even not understand which part I'm allergic to, but I'm just looking for milk at the end of the day. So yeah, I think we've got lots of lots of consumer education as well from that perspective.
Yeah. So and Linda, you are pointing out a very valuable point. Because often consumers don't know which protein in a food they're allergic to. And to determine that, you need to actually do oral target testing, which very few people are actually willing to do. So oral target testing, for the listeners, are when, as an allergic consumer, you actually go to a hospital or a specialist and they give you the allergen or the food that you're allergic to consume, and they test or they give you fractions of the allergen, different proteins, and they determine which proteins in the food you're actually allergic to. And very few people actually want to do that. So it is a little bit of a minefield and a map to figure out how everything fits in together, but I guess that is what we are there for. But yes, consumers are often not fully educated to what food allergens are and how that's allergen control actually, what that looks like in a food factory.
Perfect. Okay. A question from Ina. She's asking rapid kits for SO2. Anything like that?
So at the moment we get that question. So if you've noticed the reaction, we get that question a lot. So at the moment there is no rapid detection system for SO2, but if we find one, we will let you guys know.
And it's also important to remember SO2 is not protein, so it doesn't work.
Yes.
SO2 is not a regulated common food allergen in South Africa. There is regulations regarding SO2, but it's not seen as a common food allergen.
Yeah. So it's actually not on the list of 8 at the end of the day. Okay, ladies, I'd love to talk more. There are a couple more questions. I'd like to take one more if you don't mind, because I think this is a question that a lot of people maybe don't understand. So if all our products contain the same allergen or similar allergens, and I know there's a lot of distinction between similar allergens and the same allergen, but But I think the question comes down to a facility where we've got products that all our products contain some kind of allergen, and then we've got those where we've got very distinct processing lines where we don't want any contamination. So Nyana's question is, do I still need to do, this kind of tests on cleaning efficacy if I've got all products containing allergens in that, and sort of a mixed bunch?
So I guess it comes back to determining whether cross-contamination is possible. So if you produce products with different allergens or different combinations of allergens on the same equipment or lines, yes, then you have to do validation and verification that would include allergen testing. But for example, let's use a bakery as an example. Most bakeries in all their products, they have gluten or wheat, gluten and soy, right? So those are common allergens. So you don't need to validate the control. You don't need to control those because those allergens are in everything. But if you have one single product that contains egg, and you want to make sure that all your products that contain soy and gluten or wheat are not contaminated with egg, then you need to simply just validate and prevent the cross-contamination of egg. So I hope that answers the question. So it all goes back to doing risk assessment. You need to determine what contamination is going to happen, which allergens are you actually concerned about, on which lines is it going to happen, and which allergens do we need to effectively control and clean for and test for them.
Absolutely. Nosaseko has a similar question, and I think she's asking here specifically in relation to the kind of kit or which kit would be suitable for them. And so I'm sure that you guys will engage with all of the delegates individually afterwards. I know you're wanting to send them information about your upcoming training course. So Nosi, please look out for the response from FACTS specifically in relation to the kits that they can supply you with, because I'm sure they've got a solution for you in a ready-to-eat processed meat facility. Ladies, yeah, I'm sure you've had lots of experience in that kind of environment. Everyone is saying great. Thank you so much for the answers. Thank you so much for the presentations. So thank you very much, ladies. It was really very, very helpful. I like the fact that you are wanting to ensure that I can equipped to make the right decision. And I think that's so important in the food industry. We need to help people to understand what questions they should ask and then what are the right answers, to those questions. A couple of quick ones. Are there any legal requirements regarding the kits? I mean, because no.
The only legal requirement is that you need to prevent cross-contamination. You need to do risk assessments, and the only really mention of testing in the regulations are pertaining to gluten testing, where the method is prescripted. So no, there's no legal requirement to do any verification testing. It's all forms part of that allergen control plan.
And showing your due diligence, because allergen rapid kits and testing is at the end of the day there to show due diligence for the controls you have in place.
So indirectly, but not directly mentioned.
Yeah, I think it would be interesting to just have the discussion around ISO 17025. I mean, the testing process itself would obviously have to be validated in accordance with ISO testing methods. So I think there's probably something in that respect, and I'm sure you guys would be able to clearly guide your customers to understand why it's so important that they only choose validated test kits, because they're relying on the assurance from a laboratory that has done this testing, hopefully in the correct way, in order to ensure that they are going to get the right results. Is the rapid kit enough for positive release? So, I mean, we mentioned the difference between product testing and cleaning efficacy. In this case, can I let it go just based on that rapid kit?
So we, at this stage, recommend that the rapid kits, especially those that are suitable for product testing and ingredient testing, is used for screening purposes, because there are limitations with regards to protein extraction and matrix effects that is overcome when you do actual laboratory testing. So at this stage, for positive release, we would err on the side of caution and say rather go with laboratory testing, and then slowly but surely incorporate rapid testing once you have supporting evidence that they are going to be effective. So in this case, screening, but this is a moving target. Rapid kits are becoming more sophisticated literally by the day. So in future, it might be possible, but at this stage, we would recommend it for screening purposes.
And I'm sure we'll see development of legislation accordingly, possibly not within South Africa as fast as what we'll see that kind of process happening within the US or in the EU. So I think we sort of need to be watching what's happening in those markets. The next question I had, I think you answered, because I was going to say to you, well, you know, can I do away with lab testing, which is expensive, you know, and just use a rapid kit? But you've just told me that I can't do that because there are obviously limitations. So it's a combination of both, and that's obviously where you can help me set up a protocol that makes the most sense for my environment, my products, and my allergens. Yeah. Right, everyone? Perfect. Everybody, you know where to find them, and so please won't you reach out, but also, as I said, please look forward to an email that will be coming from FACTS literally with today before close of business about some exciting training that they would love you to join. I think after listening to this presentation, you can understand that an hour is not nearly enough to really get to grips with this properly. So I think you should definitely add this to your training plan and make sure that you engage with them. Ladies, thank you so much. I appreciate it. Thanks also to the cameraman who was in back of house there, making sure that you had we had both of you in the picture. And thank you so much for your time and all your effort and a really great presentation.
Thank you very much.
Right. Goodbye, everybody, and do make sure you enjoy the rest of your Wednesday.